Good afternoon. I'm Steve Schladover from the University of California PATH program. I started working on automated transportation systems when I was a student, which is in the early 1970s, and have been working on it since then. And throughout almost all that time, not just automated transportation, but connected automated transportation, how we can use connectivity to help make the system work better so that the vehicles and the roadway infrastructure can actually work together as an integrated system. And the PATH program in Berkeley has been doing work in this area for the last 30 years. We've done lots of prototyping and testing of different vehicle systems, as well as policy and planning studies about what the impacts would be on the transportation system.
My name is Dave. Is this on? There we go. My name is Dave Sparks. I'm a research scientist at the Texas A&M Transportation Institute, and that's known as TTI. And TTI is one of the premier research institutes in the country, probably the largest one, and we do all things across all modes. So that could be, passenger cars, it could be commercial freight, it could be drones, it could be aviation, it could be transit. It could be, ocean-going freight, railroads, et cetera. It's really kind of the whole portfolio of transportation activities, and it's here in the state of Texas. I joined TTI from an industry perspective, not from an academic perspective. I was a co-founder of a company named TransCore, which those of you here in Texas, when you pay tolls, thank you very much. You're probably using a TransCore set of technology to do that. And I ran the ITS market for TransCore that was worldwide. And the thing that's interesting about connected and autonomous vehicles, which is kind of what I'm doing at A&M, working in the space of the ecosystem, who all the players are, and some of the key things on how that's going to come together. It's a fascinating look at what may happen and how IoT has a big role to play in that space. So I'll stop there for now.
Hi, my name is Richard Soya. I work for NXP Semiconductors here in Austin. My primary role is to specify and define microcontrollers that are used in automotive electronics applications, so all the control systems that actually operate the vehicle. I've worked in this industry for longer than I'd like to remember. But back in the 90s, when I first started there with Motorola, we did a lot of the same kind of work, except in those days, there was no connectivity. And now the real issue becomes we have connected vehicles. We have to make sure that they remain safe and secure. So the challenges that we are faced with in the company itself is how to define and develop the products that will maintain the safety and security of the passengers and those around us. So we work very, very closely with all the tier ones and OEMs globally, basically, to understand the needs of the future. And that's really my role in the industry.
Thank you. We'll start with the first topic, traffic flows both on freeways and city streets. And the first question, really for all of you, is, thinking back yesterday in the plenary session, the gentleman from MIT had that very interesting video about simulating Singaporean traffic intersections. And the automated version showing traffic flowing smoothly, the non-automated version, obviously some stacking up. And the first question is, to your mind, how far away is something like that? First of all, do you think it's practical and for that to be widely deployed as a mainstream fact of life in cities? And then a follow-on, what time frame would you put around that kind of a very advanced vision for automation as it relates to city infrastructure?
I didn't see the video in question, but I've seen videos in which they assumed that all the vehicles were coordinated automatically and there's no traffic signal. If that's what it was, I'm sorry to rain on everybody's parade, but not in any of our lifetimes, and maybe never. There are several really critical problems with that concept. The first is no provisions for bicycles and pedestrians. How do they get through that intersection? The second is, depends on every single vehicle on the road being totally automated with no drivers driving anything of any of the vehicles. Not going to happen in our lifetimes. The third part is, it is a totally fault-intolerant system. A minor discrepancy on any of the vehicles that are going through that intersection leads to a catastrophic crash. I don't see that as being likely at all. There are many things we can do with automation and connectivity, but eliminating traffic signals, I'd say, is not one of them.
Anybody here see those videos on YouTube about traffic in India? You know, where you have the rickshaws and the cattle and the pedestrians and the cars and the trucks all going through a very 5- or 6-way intersection, and it flows. Nobody hits anything. There's zero traffic control in that environment because the people there locally are able to understand how to navigate in a pretty complex way and not hit anything. Maybe you got to stop for a moment, let things go, but kind of if you keep going at a common rate of speed, you can kind of pick and choose your way through this, very interesting dynamic. If you think about other places, and especially in Europe, roundabouts, it helps traffic flow tremendously. The issue with signals really is you're introducing a constraint. So if you think of traffic flow like fluid dynamics, things are supposed to flow in their own natural way. And when you introduce signals, that is introducing the need to stop. You're doing it for safety purposes. You want to do it for safety purposes. You want to improve, the performance of the whole system so you don't have these crashes. But anytime you interject a constraint into something that is supposed to flow naturally, you're going to have backups and problems. And so technology has been involved already with adaptive signal controls and so on and so forth. And as Steve pointed out, you ultimately, to kind of get to the point to where everybody is kind of on the same page looking at everything, everybody has to be connected to each other so that it will work well. And yeah, that's going to be a long way away.
Well, David mentioned the video. I think I took the video. I was in India just a few months ago, and I can vouch for exactly how the traffic flows there, or not, as the case may be. But he's absolutely right. They seem to manage to do it, and in some cases it's mind-boggling how they manage to avoid crashes. But I agree with Steve on not in our life. Except, who's the youngest person here? Maybe in their lifetime, but not maybe in ours. But I think it's only going to work. You're only going to get smooth traffic flow if there's complete interconnectivity between all vehicles and with roadside units that interface to traffic signals and various other types of information that is made available to the driver. I think it's got to be a complete package that incorporates all aspects of road use and signalling. And the sooner it comes to Southwest Parkway, I don't know how many of you are from Austin here, but I live off Southwest Parkway, and it's a 6-lane road, 3 lanes in either direction. And there's one traffic light there at a very small intersection. And there's a left turn that I have to take to get home, and it's filtered with a red light. And there's no traffic on the road at all, and the red light is on. So technically, I can't turn left. I have to wait for that light to go green. It's so frustrating when there's no other traffic on the road and you are prevented from turning into your subdivision. And the sooner we introduce automation that fixes that kind of problem, I think we're going to make a lot of road users much, much happier. So I think that's all I've got to say for that right now.
We can fix that problem with connectivity without even having the automation.
Or you can fix it just by ignoring the signal right there and continue on through.
I would never admit to doing that.
So another part of the gentleman from MIT's demonstration was talking about Manhattan traffic flows regarding sharing rides. Very complex mathematical model showing how many rides started, ended in similar locales, and the conclusion was some 40% of traffic could be taken off if rides were shared. To what extent does behavioral issues come into play here? I mean, I know I'm probably not really going to always want to necessarily share the car to wherever I'm going. So is this something where, in theory, technically it could be done, but from just a human behavior standpoint is maybe not quite so practical?
Yes, I think the human behavior is really a critical limitation in that. There are isolated cases in which ride sharing has been workable. Typically it involves things like helping people avoid queues at toll plazas so that they'll be able to get through a toll plaza by having a shared ride instead of being a single occupant vehicle. But if you wanted to do it on a general framework, I think you're coming up against some fairly strong behavioral obstacles. Think of just a woman alone at night. How comfortable is a woman alone at night in a big city going to be sharing a vehicle with a complete stranger? And then if you look at that as a vehicle that's going to be automated, that's not going to have a driver on board, there's no authority figure there to provide any sort of protection. I find that kind of hard to believe.
Okay, you got a panel here with three gray-haired white guys, and all of us grew up with our parents telling us, do not get into a car with strangers, right? You know, a lot of y'all are nodding your heads too. So it's a different dynamic, and when you look at the behavioral things that go on with people's decisions today, you know, think of Facebook, online connectivity, how free people are with privacy around, you know, what they're doing, where they are, notwithstanding that, you know, we're supposed to be able to keep things confidential and private and control that for ourselves. There's a lot of, you know, people have pretty much flushed that, you know, away in a lot of cases. And so this whole behavioral piece of that activity and, you know, if you're getting to what impact that may have with ride sharing on streets, you know, nobody really knows. And what I mean by that is when you talk to DOT heads, you know, they're not sure with the emergence of ride sharing or ride hailing as a business model, instead of parking a car, are you going to have these folks circulating around waiting to get pinged on the app that people will have to say, hey, pick me up here and take me there. It is filling a niche, obviously, because you're dealing with an alternative where you're able to, you know, close that last mile transit gap, if you will, where you don't have to walk if you don't want to, if it's inclement weather or you have some issues or you have some baggage or luggage and so forth. It's a convenience factor, and that's a pretty important thing. But, you know, if what you're going to do is part of this is you're going to introduce a lot more congestion and traffic circulating around looking for the next ride instead of those vehicles going off and being parked. And as some DOT folks will say, is we don't know if on the net basis that's going to put more traffic on the roads and make the problem worse, at least in the initial term, as opposed to maybe, you know, if you do a Rumpelstiltskin analysis and think, well, I fell asleep and I woke up 50 years, then we all figured it out and it might be a lot smoother.
Well, I'm not sure I've got an opinion on ride sharing, actually, except I think the safety of you know, the passenger that gets into a car with a stranger, that's possible that kind of problem could be resolved by having some kind of ID or passport or whatever you want to call it that the driver retains and somehow communicates that some kind of statistic or information to any potential person that needs to share that vehicle. So that would introduce some form of sort of ID system that maybe helps resolve at least the security problem that a lot of people might be concerned about. But again, you know, if you've got a lot of people driving around in cars waiting for somebody to pick up, then you could increase congestion as well. I don't know what was wrong with Uber here. They're obviously not around anymore, but you know, that style of sort of on the spot taxi service seems to be, or on demand taxi service seems to be a better approach. I don't know if your term ride sharing is something different to that. But I think it's all a question of degree, I suppose. I think that's all I've got to say for that.
Well, shifting gears a little bit and moving on to DSRC and cellular vehicle to everything, the automotive industry seems to have been working on DSRC for 15 plus years now. Representatives have just gone to the new FCC chairman and asked for protections of the 5.9 gig spectrum. When you look at DSRC versus CVTX, how do you think this plays out over the next 5 years? Does the automotive industry finally get all the pilots wrapped up for DSRC and it's their path forward, or do you think the mobile industry's CV2X has legs, has an opportunity here?
It's not an either-or situation. These are two complementary technologies, and they both have roles to play. The DSRC has been under development for 15 years. There are many technical challenges that had to be worked through, but it's been designed for time-critical, safety-critical applications. It's been designed with a high degree of security overhead on top of it to ensure that those messages can be received. When the messages are received, that they can be trusted. So that is really needed for the cooperative safety applications, the applications that deliver collision warnings, that do cooperative vehicle control, in which it's absolutely critical that the message gets through within, at most, 100 milliseconds. And if you've got other applications that are not so time critical and that are not safety critical, then certainly the cellular technologies are probably going to be more suitable for that. At this point, I still see 5G as a lot of smoke and mirrors, and we'll see what it turns into when it grows up. But for the time being, for the safety critical, time critical applications, the only one that will serve those needs is the DSRC.
I think that's spot on. When you think about what's happening on technology life cycles, if you took these two specific technologies, and we'll say cellular vehicle to X really is referring to 5G. Let's just take that as an example. You know, you're going to have different life cycles of technology curves and how those are going to happen. And the key things with DSRC is you're going to have these safety features on the vehicle, which is the key piece to it. That's why the spectrum so far has been protected. You know, who knows? You know, if maybe we took a poll here, my guess is that it's probably going to have to open up to sharing. But you don't want to legislate or mandate a technology forever. So, you know, Steve's talking about is going to be an and. And so as the other technologies on the cellular bands come along and are able to effectively provide the same kind of applications and benefits, so in 5G, you know, the way it's designed to work is you have a device-to-device functionality that should be in there. Well, if that can have the same safety message protocols and performance, that's fantastic. And the gentleman to my right is probably going to talk about their products where they're going to have multiple kind of frequency hopping capabilities at some point to where, you know, based on what the communications topology is with where you are, you want to make sure that you can talk to everybody on every bandwidth that you need to be truly connected and so forth. But those are going to take some time to kind of play out, and then you got to introduce them into the model years of the vehicles that have a long lead time, and they have to test them. In the whole testing regimen, from a vehicular standpoint and getting the safety certifications, all those kind of things, that is greatly underestimated, except by people who are in the automotive industry.
The way I see it is that I think there's three sort of issues with CV2X, the cellular technology. One is really the latency or the time for messages to arrive between vehicles. And Stephen mentioned 100 milliseconds. Well, it's actually a lot faster than that. It could be in the 10 millisecond to 5 millisecond range for the safety critical messages. In addition, there's a huge amount in order to manage the security of those messages. There's a lot of signature authentication that has to take place at the rate of 1,000 per second, and maybe even more than that, depending on the amount of traffic surrounding you. So these are all big challenges. The other one is really the amount of data that has to be distributed or transmitted per vehicle. And if you add it all up, it could have an impact on a cellular network, and cellular networks operate on a particular business model where they charge for bandwidth usage, whereas the DSRC, there is no charge. And lastly, I think it's the DSRC actually works on a peer-to-peer sort of connectivity that does not require a network. So if your network goes down or if you go out of range, then you've no longer got that capability with CV2X. And also, cellular by its very nature, you are jumping from one cell to another. So you've got to try and maintain some kind of seamless connectivity as you do that. So there's really a lot of challenges there. And it probably has got a use, as Stephen said. It could coexist. But in order to achieve the kind of performance and reliability of DSRC, I think that may never happen, and certainly 5G isn't going to help that at all.
Okay, well, our time is winding down, and I do want to get audience questions. So let's quickly just talk about cybersecurity. And the question is really, obviously some very high-profile cybersecurity incidences around cars, some of them from white hat hackers, but nevertheless showing pretty distinct vulnerabilities. How does the car get secured?
Well, it takes a lot of work. I think the main point is that's an issue that's with us here and now with any modern vehicle. It's not something that is exclusive to future connected and automated vehicles. So it's definitely an issue.
You know, if you think about best practices when you develop code and systems, you can't come along after the fact and say, okay, I got this great operational system and now I've got to put a security wrapper around it. That doesn't work. You have to internalize and implement security from the first line of code you're implementing at any kind of functional level, so it has to permeate the entire development process. So the ability to come in and kind of do it after the fact is a weak solution, in my opinion, to this. So whoever's going to be developing these applications and providing the security components to it, I think is critical. Just out of curiosity, is anybody else in here from an InfraGard member? Okay, well, InfraGard, just so you know, is a public-private partnership between the FBI and cybersecurity professionals who work together to try to identify and deal with threats, because these are the things that executives of businesses are really worried about. How do I, not so much even how do I develop it the right way, but what are the preventive measures and what are all the things I need to be doing to get involved with that? So if you're interested in kind of selling to this market, I just want to put out there, please take a few moments to think about if you're interested in that space. Get involved with InfraGard, because you're going to see things, because you get some clearance, you have to go through an application process. But if you get into it, you're going to get some insight into what's going on, and hopefully before it ever hits the news, and never hits the news, because you're going to be within a group of people that'll be focusing on that situation.
Yeah, so I think contrary to what some people might think, the ability of vehicles today to be secure is very, very limited. The attacks that were done last year, the hacks on various nameless manufacturers' cars, where you could take complete control from a laptop through a Sprint cellular network, those kind of attacks were caused by embarrassing sort of oversights in the way that the system was put together. However, very few OEMs at this point in time have got vehicles out there that contain very, very strong cybersecurity solutions. The concept of cybersecurity involves encryption, authentication, etc., those kind of things at the very fundamental electronic control system level in the vehicle. That is not in place today. That is only now, the specifications for those things are only now being worked out by organizations like SAE and IEEE. So these are brand new things that have still to come in vehicles. And the development life cycle of vehicles in the region of 4 to 5 years. There's a lot of challenges by trying to define and design something today that isn't going to go into production for 4 years when everything might have changed in terms of the types of attack surfaces and general attacks that can be launched in vehicles. So it's a big, big challenge. And there are many people working on coming up with good solutions for the future. So I think we ignore this at our peril today if we think it's all been solved.
Folks, I'm sorry, we've come to the end of the time. If you have further questions, perhaps our panelists will be kind enough to speak with you one-on-one about that. But
Or some of us have subsequent sessions.
Or that's
So
very
it's a
true.
reason to stay later, so that we're not all by ourselves.
Yes, yes. So please join me in thanking our panelists today.